talk about some logic operators. Sometimes you can call them digital logic. It's the same thing, huh? Like digital logic. Right? You know most of the devices that we are using, right? The electronic devices. Those devices use this what? Logic operators, right? But the basics one, there are three that you have to know. There's what we call, there is AND, there is what? And there is a NOT, right? There is AND, there is OR, and there is a NOT, right? This AND, this is what we are going to use the most, like here, right? We call it the ending logic. The ending. We're going to pick the ending logic. What does it mean with this ending logic? It means this. This is the table. Right? Right? 1 and 1. Okay. Let me give him name. Okay. 1 and 1. Yes. Well, you cannot see. No, I'm just writing. I'm not explaining from here, right? Okay. Then just do it. Let me remove this table. Sometimes it can give you a headache. Okay. First, what you need to understand is this. 1. It means also what? Wherever you see 1, it means what? True. It can also mean like what? Like on. So when there is electricity, you can represent it by 1. 0, it's also what? False. You can also say it's off. Right? Now, you can try to compute. Right? 1 and 1 will always give 1. 1 and 1. It's always what? 1 and 0 is what? Don't try to calculate. Don't try to. 1 and 1 is 1. 1 and 0 will give 0. 0 and 1, it's what? 0. 0 and 0, it's this. The only case you get 1, it's 1 and 1. Right? What does it mean? Logical, I don't want to go further, right? It means this. So if the first proposition is true, the second also is true, the ending will be also true. Right? See, when you ask your computer to play a movie, right, by using the correct application, that event or that instruction can be said it 1. When you ask again your computer to open Microsoft Word and you did it the correct way, so it's also what? 1. Now when you want your computer to execute those 2 at the same time, it means what? Play movie and open Microsoft Word. If those 2, you did them the correct way, the final result will be what? Will be true. Your PC will play the music and open Microsoft Word. Right? This is right. So you can represent something by using 1, like an event, like pressing, typing. You can say it 1. Right? Just that. Don't go there. Electronic and so on. For you just know true operation and true operation gives true. True and wrong, it's wrong. Wrong and true, it's wrong. Wrong and wrong, it's wrong. Finished. Right? You understand? 1 and 1, it's 1. 1 and 0, 0, 0 and 1, .000, it's Z. Now when they're gonna give you a calculation, they can say this: 1 1 1 1 1 1 2 3 4 5 6 7 8, right? And they're gonna say and 0 1 1 0 1 1 0 1. They're asking you to compute what? The end, right? Let us underline here. Now you, what you're gonna say, you just follow. 1 and 1, 1 and 0, 1 and 1, 1 and 1, 1 and 0, 1 and 1, 1 and 1, 1 and 0. Right? And you know how to convert these in decimal. Right? But later on. For now, I wanted you just to understand how to compute, how to find the end. Right? Any question? What you did here? You just follow this. 1 and 1 is 1. Right? Difficult? No. This is how computer do the calculation when it comes to IP addresses. So they have to convert it like to be at binary. They have to compute the end logic, and they're gonna find the network part and the host part. But for now, I'm just first showing you how to do it, right? Let me give you an example, right? Can I wipe here? Let's say somebody will tell you, okay, this is the subnet mask. 255.0.z, right? Now you're gonna convert it in binary, right? This 255 is what? 1 1 1 1 1 1 1. It's 8 1 1 1 2 3 4 5 6 7 8, right? You put what? So 255 is ones, but 8 ones, right? That's why we call it what? Network bits. So network bit is always 1 1. Wherever you see 255, it means 8 ones. But here there is what? 0. It means the host part. You must put 8 zeros. 1 2 3 4 5 6 7 8. Again, 1 2 3 4 5 6 7 8. Dot 1 2 3 4 5 6 7 8. Right? So the subnet mask is this one. But in binary, right? Now when we are saying let's borrow 3 bits, you remember from the calculation, right? From where we're gonna borrow? From the zeros, right? So borrowing like 3 bits means that you're gonna change those 3 from 0 to 1, right? So it's gonna be what? Okay, let's say we want to borrow 3 bits, right? So we're gonna borrow from where? From the zeros. Remember what you've been doing. So borrowing means that those 3 zeros must change to what? To 1. So it's gonna be 1 2 3 4 5 6 7 8 dots. The zeros will be 1s. You remember from the theory. Yeah. 1 1 1. You stop there. 0 0 0 0 0 dot 8. Dot 1 2 3 4 5 6 7. Right? You don't understand? Borrowing like 3 bits from this subnet, right? It means this. How many ones now are here? How many ones? There are 11, right? So the network part is which one? This is your network part. And your network part will have how many bits? Right? Your host part is what? Here. How many bits here? 16 plus 5. That's going to be 20? 21. First, left is what? No, you convert this to binary, right? No, you convert this to binary, right?
Yeah.
Now they are asking you to borrow 3 bits. Where are you going to borrow? From the zeros. Borrowing means you have to convert 3 zeros to ones. Now they're going to be ones, right? Are you with me? Now they're going to ask you what's going to be the new subnet from, right? Because you are modifying your subnet mask. What is your new subnet? Your new subnet mask. Now, what we're gonna do is what? Those 8 bits, those ones, it's what? This one is 255, right? This one is 255 dots, right? Now this one is what? You remember? 1, 2, 4, 8, 16, 32, 64, and 192, right? So 3 bits is this. It's 192 plus 60 plus 30. You know how to convert from binary to decimal. You only write what? Like on top. 1, 2, 4, 8, 16, 32, 64, and 120. But you cannot consider the z. So you can only do what? 192 plus 64 plus 30. So the answer is going to be what?
So why are we going?
What are we what?
Why are we going to reverse?
No, according to the formula. You can even go like this, so it's going to still give you the same answer. So what's going to be the answer? 192 plus 64 plus 32? It's what? 192 plus 64 plus 32. Fast for me. Okay. Fast, guys. 192 plus 64. 64 plus 32 is 96. 192 plus 96. It's 8. 8, 1.
28. Which number are we trying to get? I don't understand.
No, it's 128 here.
Oh.
It was yeah, because I see like it's a lot here. That's why. 128 plus 96 is what? 250? No. 254. 254, huh? Okay, 254. Hey guys, don't be wrong. 128 plus 64 plus 32 is what?
224.
224.
Yes.
Are you sure? Okay, 224. So your new subnet mask is gonna be 255 dot 224 dot 0 dot z. You don't touch that one.
I don't understand it.
This is the new subnet. I'm gonna repeat. I know I have to repeat, even though don't ask me. Okay, let's start over. Don't even write. I'm gonna start over. Alright? Okay, let's say you have a default subnet. They're gonna give you a default subnet, right? Your provider will give you an IP address and a default subnet. Maybe the default subnet is this one. It's 255.0.0. This is class A, right?
Yeah.
You have to convert this one to binary. We're going to convert it to binary. But converted is 255. We know the answer is 1, 1, 1, 1. It's 8 ones. it's what? Dot. When you convert this one, you're gonna get, you know how to convert. The remaining one is 0, 0, 0 everywhere. 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Dot. Because this is an octet, those are the bits. One octet is 8 bits. Dots 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? So here we are dealing with octet, but here we are dealing with what? Bits. Right? One octet is 8 bits. One octet is 8 bits. One octet is 8 bits. Right? Now from here, right, you must know that the exercise can be, they will tell you, or yourself, you say, okay, I want to borrow maybe 4 bits, maybe for 16 subnets, right? You will know how many bits you want to borrow for a specific subnet, right? Let's say you want to borrow maybe 2 bits, right? You want to borrow 2 bits from where? From the host. From the host bits. Right? We want to borrow 2 bits. Right? We're gonna borrow where? This is your network part. You want to touch here. Wherever there is 1, 1, 1, 1. Don't touch. This is what? Your host part. This is where we're gonna touch. Where's my red pen? I need marker, please. Okay. So we're gonna look at where? From here. This is the host part. Right? So this is where we have to start borrowing those 2 bits. Borrowing means we're gonna change those 2 zeros to 1s. Right? So these whole things will change. So it's gonna be, this will remain, right? So I'm going to wipe those 2 zeros, but you're gonna write it down, yeah? First you write this, and you write the new one. So I'm gonna wipe those 2 zeros. They are going to become what? 1, 1. Right? Because of this requirement, right? You're gonna change that. If you are borrowing 10, you're gonna change here 10 zeros to 1s. Now, when you change it like this, right? You have to convert now this part to binary, right? Because this one, you know already that it's what? You cannot touch it. It's already 255. This one you cannot touch. This one, there is no one. There is no one here. You cannot touch anything. You cannot touch. It's gonna remain 0, 0. The only things you have to calculate it in binary is what? This only, right? So let's convert this part to binary. Let's convert it. So it's 1, 1, and 6 zeros, right? Remember that in binary, we discussed about it long time ago. You must start, you say 1, you say 2, 4, 8, 16, 32, 64, and 120. There's no calculation, so you only take like the double. You said, okay, I'm gonna start 1, 2, 4, 8, 16, 32, 64, and 28, right? But these ones, they are zeros. Means you have to cancel them. You cannot consider them. Right? We're gonna cancel this one. From here, from 32, it's out. So we remain with what? We're gonna remain with 128 and what? So the answer of this whole binary things in decimal is 128 plus 64. That's gonna be what? 190, 192, right? So when you got this 192, you must go back here. You replace where there is 0. You replace by what? 192. Easy. So you're gonna have now your new subnet mask gonna be, yeah, dot 192 But those two, we don't touch them because they are zeros. Dot, 0, dot, 0. Finished. This is your new subnet mask. Right? I'm gonna repeat again until you're gonna be sharp. Right? Until you're gonna be. Yes, let's do the last exercise before me giving you yours. All right, I'm gonna repeat again. We're gonna borrow maybe 6 and so on, right? Because some exercises they will just ask you, what is the new subnet mask when you are borrowing this number of subnets, right? Let's do another one. Can I wipe? Let's start again, all right? So let's say you have a class C, right? This is your default subnet. Dot 0, dot 0, right? Means you are not concerned about this one, right? You're going to be concerned about what's coming after. But you must know that 255 is what?
8 ones.
Yeah, 8 ones. 1 octave at 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Dot. This 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? Now the exercise can say this. Borrow maybe 6 bits. You want 10?
Yes.
Borrow 10 bits. Right? Because you know your requirements may be, and you know how many bits you must borrow, but what's going to be the new subnet? Right? So we're going to borrow 10 bits. Right? Borrowing 10 bits means that you must go back here. Right? But this one, it's your network part. You cannot touch. This one, the ones, it's your network part. You cannot touch. Right? You must start from where? From here. This is your host part. Right? So when we are talking about borrowing bits, we're going to borrow those 10 from where? But borrowing means we're going to change 10 zeros to 1. Right? So the new subnet is going to be, so I'm going to change here 10 bits to 1. Right? So I'm going to wipe those zeros. They're going to be 1s. Right? So they're going to be now what? 1, 2, 3, 4, 5, 6, 7, 8. You put dots. 9, 10. Right? The only thing that's left is what? You have to convert this in binary. In binary, finished. How to convert this one? You know already it's 250. Let's do it. Maybe you are not sure. Let's convert this one like in binary. 1, 2, 3, 4, 5, 6, 7, 8. You're gonna put your table down there. 1, 2, 4, 8, 16, 32, 64, 120. 128, right? But if you do the sum of everything, because there are only ones, so you have to do the sum of everything. So the answer is going to be 250, 255, right?
Yeah.
So because you get already 255, your new subnet is going to be what? 255, dot 255, you're going to add what? Because this 0 is going to be replaced by what? By 255. But we are not done. This one is remaining, right? We have to convert also this one because there are some ones here. We're going to convert this one to binary. So what you're going to do again, you're going to take this one. 1, 1, 1, 2, 3, 4, 5, 6. You do again your table down here. 1, 2, 4, 8, 16, 32, 64, and 128. Because you have zeros there, so the whole thing will do what? Will fall, right? You're gonna only remain with what? 128 plus 60. That's gonna give you what?
192.
190. You are done. So this 192, you're gonna replace what? So the last bit is 190. This is your new subnet. So new subnet mask is what? 255.255.255.190. 192. Yes? 128 plus
64.
it's 120, 192. Right? So you see that the new subnet is gonna be what? How many bits for the network? 16 plus 8 is 24. Plus 2, that's gonna be 26. Right? So 26 for the network. And how many for host? 1, 2, 3, 4, 5, 6. 6 bits for host. For host,
And 124.
126. Yeah, 26 ones.
Yeah.
For what?
For network.
For networks. You can also write it as a /26. This is the prefix. Right? Okay, we can stop by there for now. Right? Wait. Now, let me give an exercise. Right? You have to practice yourself again. I will see. Let's use a class C. Right? This one. What happened to my marker now? The marker is dead. We're gonna use this one. 255.255.0. It's a class C. You have to borrow 20 bits. No, we cannot borrow it too much. You are clever. Now you can see already that no, 20 bits is impossible because there's only 8 bits here. Yeah, now it's fine. You can understand. Okay, you're gonna borrow 5 bits, and your job now, you must show us the new subnet. The new subnet is what I wanna see. Okay.